Alrighty. So, hello everyone, and welcome to the TE After Party. My name is Patrick, and I'm going to be your host for tonight. I hope that you're all enjoying Cannes, and then the heat is not hitting you too much, because we have a pretty spicy agenda for tonight. So, I've even heard some rumors that there will be some announcements being dropped tonight. So let's see what the future will bring. So today on the menu we have 4 keynote presentations. We have 1 panel discussion. And yeah, we're all looking forward to that because after the presentations there will be also an open bar and some open food. So yeah, I hope that we're gonna all have an option to, have a quick chit chat after that. Alrighty, so let's kick it off. Let me invite on the stage the CEO and co-founder of Oasis Network, Jernikos.
Hey, thank you, Patrick. Thank you, everyone, for coming. Yeah, let's begin. So maybe first thing is, I'm sorry, but I have to ruin the party a bit by saying that sorry teas are not enough. So just don't tell it to my wife. Her name is T, so don't tell her that. Why? So hopefully people here don't believe the stories that you can just put things in a tea and it's suddenly secure, because that's not true. So they said. So let's first see what's there in a tea. So what are the basic components that we have, that we get from a tea? So the first thing is isolated execution. So basically a place to execute your binary code in private. And their state is either local or encrypted. There's something wrong? Okay, cool. Cool. The next thing is, well, each CPU needs a key or a set of keys, basically that are internal to the CPU and are used to encrypt data and sign messages. Currently, these keys mostly live in so-called e-fuses, but hopefully in the future they will be more secure in puffs, so physically unclonable functions. That's the next thing. And the last but not least is the remote attestation capability. So basically a way to prove to third parties that correct code is actually running in a specific TE. That's usually achieved in these protocols by generating a signed quote, which can be verified. So that's it. That's a T. Is that enough? Well, there's, I think on this slide, like 2 things. First, I mentioned in remote attestation, well, you prove to remote parties that you're running the correct code. But what is correct, and who decides what is actually correct? And the second thing is, well, if there's a specific trusted execution environment, which one, and who decides which one is the correct one? But let's get to that in a bit. Is there anything else that's needed for, well, having a secure TE framework? Well, maybe not. But what happens, for example, if the CPU where your TE is running gets destroyed in a fire? Well, suddenly you lose the CPU and you lose the root of trust. So you lose all of the keys that are present in the CPU. And obviously the point of those keys is that they can never be extracted. You can only get derived keys from them. So if you've encrypted any state with those keys, well, sorry, that state is now lost. So even if you made backups, well, the encryption keys are gone, so you cannot actually read anything. So that means that we need something like a key management system. So what is a key management system? Well, it's a system that holds its own set of secrets that can be used to derive application-specific secrets for correctly attested TEs running the correct code in specific trusted execution environments. Okay, so where does it live? So ideally, it would run a bunch of replicated TEs which are also geographically distributed so that, well, they're more resistant to fires because you don't want your teas burning down. But then again, we have this issue of what is the correct code and what are the specific trusted execution environments that are valid. Okay, so that means that we still, even with the key management system, this is still not enough. So maybe we also need some boring things called policies. So what are policies? Well, policies are documents that say specific things about our teas. The first thing is basically which is the correct code for our app. What does that mean? Well, the policy has or needs to have basically the identity of the binary code that's running in a TE and that's deemed correct. Why is this important? Because this code will have access to any application-specific secrets. The next thing is what is an acceptably secure TE that our app can use or is allowed to use. Well, what are the security version numbers of the various components that comprise a TE? For example, firmware updates, microcode updates, and so on. How often does the application need to reattest? These things go into the TE policy. And last but not least, there's also the question of where is the code of our app allowed to execute? Because sometimes maybe you're paranoid and you only want the code to run on specific providers or even on specific machines, on specific providers that are administered by specific accounts. All of these things go into a policy. And the best place for these policies to live is obviously on chain with dedicated app governance. And that is who decides on what is the correct code and what is the right TE and where it can run. We mentioned the identity of the binary code. So the first question then is, so what about audits, right? But first about governance. With governance, we definitely want transparency. Why? Well, because software is not static. There's always updates. Why is that? Well, because software has bugs, and we need to fix them over time. And we need to make sure that all the updates are actually equally secure than the original version. So we need transparency to know all of the policy changes that happened over time so that we can be sure that all the changes were properly audited and approved. And then again, what about audits? Well, for audits, we need a thing called reproducible builds. What's the idea? So the idea is that we audit the source code of all the components that compose the apps. And then from that source code, we can deterministically build the binaries from that source code. And we can derive the exact same binaries, and we record the measurements of those binaries into the policy. So we can be sure that only audited apps can actually run in the TE, and that secrets are only disclosed to these audited apps. And it's very important that anyone can reproduce the same binaries from the source code, so that anyone can independently verify that this is actually the source code that comprises the app. Okay, then for ease of development, we also want to support this cool thing called containers. Why? Because, well, there's a bunch of existing apps that live in containers. But of course, there's also what about the apps that require smaller TCBs? Well, that should still remain an option. And besides governance transparency, another important part is also having a history of all the app replica executions. Why is that important? That is important so that we can be sure, we can be aware of all the replicas of the TE app that ever run. And we can inspect that and make sure that they all complied with the policy and that all the changes and all the things were approved by governance. And also another thing, that we can have the apps basically require that they first register in this transparency log, which lives on chain, before they execute any other logic. So there's no way going around this, because the app would run a light client inside the TE to prove that. And last but not least, there's a question of TE providers. So basically where you can host your TE apps. And I believe that it's very important that all the things are decentralized. Otherwise, what's the point of Web3? So that means that we need decentralized TE providers. And we need to make sure that all of these apps that run in TEs are easily portable between these different providers. And not only that, but also that the deployment experience is good even if you switch providers, so that you don't need to do everything on your own just because you want to run it in a different place. So that's quite some stuff that's needed to run security apps. And that's the reason why at Oasis we've built ROFL. So what is ROFL? Well, the idea is that secure and decentralized defaults are important. Why? Because, well, if the defaults are not secure and decentralized, people will take the easy path and just build insecure and centralized apps. And we don't want that. So what is ROFL? ROFL is a framework that provides all the things that I've mentioned before. A decentralized key management system, app policy management, execution transparency, reproducible builds, and a decentralized TE marketplace. So all these things easily, nicely packaged into a framework that, so that you don't need to worry about all these things because they come by default. So for developers, this means that it's very easy to create and manage and build and verify apps and access secrets, generate secrets, deploy them to TDX machines, and so on and so forth. For providers, this means there's a marketplace where, well, anyone can provide their spare TDX resources, and even, which is useful even if you want to run on your own infrastructure just to get the easy tooling to deploy your TE apps. And of course, we provide a reference implementation of the scheduler to do all the management of the virtual machines for you, so that the providers don't need to do much. Cool. Then there's another thing. It's called ROFL.app, which is a web front end for managing all things ROFL. This is a nice thing that can be used for a quick overview and management of all the ROFL apps, deployment to providers, and we'll be adding more features as things progress. And this nicely complements the CLI, which can be used for more advanced stuff. So, what can be built with all of these things? I guess we've heard this in the past few days, and we'll hear it more in the next few presentations as well. Well, one thing is definitely trustless DeFi agents like WT3, which can automatically perform actions in various DeFi protocols without obviously the operator having access to any funds or any secrets like, for example, private trading strategies. Then obviously oracles, and at the end, of course, private AI inference with support for accessing GPUs from TDX instances. Yeah, so thank you everyone. Go to ROFL.app and try it out.
So, thank you very much, Yarnay. Alrighty, let's continue with the agenda. So the next presentation will be from Ricardo, who is the ecosystem manager at iExec. Ricardo, please welcome on stage.
Thank you so much.
Yarnay, how are you? Okay. Nice. We haven't met. Great presentation.
Bro. Okay. So, good evening, everybody. I'm Ricardo, ecosystem manager at iExec. So I manage the ecosystem and also partnerships. Thank you so much today for coming to the tea party. Unfortunately, we're not going to be serving any teas. There's alcohol, free alcohol at 8 p.m. So get ready after the presentations. And today I'm really happy to share more about iExec, what we're going to be doing, and what we've done successfully over the past year. So iExec can be summed up in the trust layer for DeepN and AI, mainly meaning we secure the whole data pipeline, enable monetization, and we build trust for users and also for developers and projects who utilize our tools and infrastructure. And of course, when we want to talk about data, we need to specify the whole data life cycle, and what type of data are we talking about. So data has 3 cycles. At first, when it's at rest, it's chilling in a data server, in an SSD or somewhere. It's not doing anything meaningful. And second, it's in transit, so when it's being sent from point A to point B. And thirdly, when it's being used, so it's when it's being encrypted, decrypted, used like a game, you're playing a game, or just opening an image, a file, so on and so forth. So these are the major 3 stages of data. And in each stage, there's a percentage or a chance that this data might get hacked, or there's like a malicious actor that might get in the way and steal your private data. So in order to protect that, iExec provides keys and trust and privacy. And how do we do that? So basically, we enable confidential computing with our T, or Trusted Execution Environment infrastructure, powered by a decentralized CPUs and GPU infra. In addition, we've built developer tools, or SDKs, that anybody can integrate easily into their application or platform to be able to interact with these T's and privacy-preserving tools that I will talk to you about later on within the presentation. And just to say, I'm a business guy, I'm not a technical guy, so it's gonna be really easy to understand, not so technical, and I'm not gonna mention any type of code in here. And at the end, in every step of the way of the data lifecycle, you can monetize it. You can encrypt this data, share it with certain people, because you have the admin rights to the T's and what's passing through it, and also at the same time create a business model and generate revenue from it within your DApp and use case. And because right now, as you know, the hype is all about AI agents, machine learning and all that, and AI is basically data that is being learned within algorithms, we need to protect that also. So iExec has presented confidential AI. This is where we encrypt AI-related data into T's or enclaves, black boxes, in order to keep them secure and private. And how do we do that? When you think about AI, you need to understand the whole AI life cycle. And in each step of the way, iExec can protect and encrypt this data. At first, the model, or the AI model, the data itself, which is being consumed by the model, the inference or the continuous usage of the data within the model for it to be able to learn what's happening, the training itself, the result, and to simplify things as the prompt and also the answer that it gives later on. So each of these steps can be encrypted and also monetized at the same time. So, for example, if you have an AI model, you're interacting with it, the prompt that you send to this model, you can encrypt it, and the model itself or the admin can pay for you to train the model with the data that you've inputted. And at the end, in order to access the answer, also you can encrypt it and gain some type of token depending on the model itself that is playing around. And after that, because we're positioning ourselves quite well in AI, we're switching from SGX, or software guard extensions, to TDX, trust domain extensions. This is where our computing power and also encryption pipe flow is gonna be 5 times faster and much more reliant, especially when we're talking about AI. And of course, with this AI specifications and integrations, we need to create a use case. This is where now with iExec, you can launch AI agents within T's, or Trusted Execution Environments, while utilizing the ELIZA framework. And also you can monetize it at the same time, creating a new type of agents, which are confidential agents. And because, as I mentioned, we're more and more putting hands-on AI and confidential AI, we're happy to partner with Aether, the leading GPU and computing power provider in this space. While they provide us with GPU computing power, we've created a new worker pool that will be able to process more and more AI-based data and machine learning algorithms to give our ecosystem an easier way to interact with confidential AI and make AI trusted more and more in the Web3 space. And of course, with all these technical integrations, we need to implement them somewhere. So we're also really happy to join the AI Unbundled Alliance, where you have at least 20 AI-focused members when it comes to infra, AI agents, AI tooling, and hand in hand, we're going to grow these ecosystems and also gain more and more traction and adoption. So I've talked a lot about what we've been doing right when it comes to AI and our positioning. I think it's time to talk about our SDKs and tools, mainly our offerings that we bring to the table when a builder or project wants to interact with our T-native infrastructure. So first of all, we have iApp Generator. To sum it up, iApp Generator is a CLI, or a command line interface. For non-technical people, you can consider it as a developer environment when you can easily interact with our Ts, because to interact with Ts, it requires a lot of knowledge for confidential computing and all that. So right now, with only knowledge in Python and JavaScript, you can integrate T-based solutions into your use cases and also monetize them. And with this new app generator, we've created also use cases in-house that builders and projects can integrate. First of all, we have Web3 Mail. This is where, let's say a project integrates Web3 Mail, he can send confidential emails to his users without looking at the email or revealing the email itself. And the user, from a user point of view, receives the email or the push notification or the newsletter or the alert into his personal inbox. This is where we keep the anonymity of the person and also stay on the ethos of blockchain and decentralization. And in this use case, the user's email address is encrypted inside the T, and the platform can only see his EVM wallet address that is linked to the protected data which is hidden. And because we had a lot of feedback from our community when it comes to privacy-preserving messaging tools, we've also launched recently Web3 Telegram. The same idea as Web3 Mail, but you can send confidential messages on Telegram without revealing the Telegram handle or the Telegram chat ID. And these use cases are really interesting when it comes to privacy preserving and anonymity, especially for DeFi applications who don't require KYC. And basically, when you provide your personal email address or Telegram handle to a DeFi platform, you're KYCing yourself. Sorry to say that. So keep everything safe, keep it secure, and now you can trust all the platforms that you interact with the help of our SDKs. And now, after talking about all our SDKs, I think it's time to talk about new partnership with Arweave or AR.io, where the protected data from Web3 Telegram can be stored on the perma-web on Arweave, keeping it decentralized and without any malicious actors tapping into it and changing it when it comes to the storage. Currently, builders or projects who integrate our tools can either choose IPFS or the interplanetary filing system, or Arweave, which is a decentralized solution for storing data, and now encrypted through Ts. And here's a small QR code. If you'd like to scan it, it's going to take you to our homepage, the demo homepage. You can firsthand try out our confidential messaging tools from a user's perspective and also from a builder project's perspective in order to better understand what's happening, and you can track the whole confidential tasks execution on the blockchain. And I think I've talked a lot about our SDKs. I think it's time to talk about what we did right in 2026, 2025, and what we're going to be doing in the second half of 2025 until 2026. Okay, perfect. So we're really happy to say that with all these integrations, use cases, SDKs, tools, we need to support builders when they integrate them. So last month, we announced the $1 million ecosystem fund, and we're ready to fund any kind of project who has a really amazing use case that fits within our criteria with money to develop their tools, their use cases, their business models, and monetize the whole encryption process along the way. So again, if you're interested in our solutions and privacy-first preserving tools, you can just talk to any person who has a T-shirt or a TE shirt, and we'll help you understand more and more how we can accompany you during this whole process. And of course, two amazing partnerships that we announced with Aether for GPU worker pools and also with Arweave for storing encrypted data on the perma-web. More partnerships are gonna be coming in until the end of the year, notably with AI projects, AI agents, which is going to be really nice when it comes to AI acceleration. And of course, the major news of today is that our native T infrastructure is gonna slowly be available natively on layer 2s and blockchains in the near future. That includes bridges, token transfers, swaps, liquidity pools, making iExec not only the trust layer for deep and AI, but also the trust layer for layers. Thank you very much. It was really amazing, and enjoy your night. Thank you, thank you.
Well, thank you, Ricardo. So let's continue with the agenda. Let me invite on the stage Wen Feng from Fala Network.
Thank you. Okay, hello everyone. I'm Wen Feng from Fala Network, and I'm an engineer. Also, I'm head of AI at Fala. So today, the topic I'm going to share is TAE, the building block for confidential AI. And before we dive into the TAE part, let's take a look at what happened on Web2 AI today. So last month, Anthropic just dropped a white paper regarding the confidential AI, which they leverage the TAE to build the private LLM inference service. And also another startup incubated by Y Combinator. Last month, the first time they rolled out the private chart based on TAE, which actually got the 2 times over subscription. And also another Web2 company like the Oppo, which is I think is the biggest mobile device manufacturer in China. They partnered with Google last year to build the PCC, which actually is a private computation cloud. And also Apple, which built the PCC started very earlier, which for now it was focused on to bring the PCC to the confidential AI. Okay, so let's first take a look at what does the TAE-based confidential computation means, and what's the benefit of the TAE-based computation. So first is the hardware-based isolation, and for both the CPU, GPU, even NPU computation, in the memory isolation, also even the disk. And another one is the cryptographic attestation, and then it can be used for everyone to verify the integrity and the computation, the execution of the code. The third is the circuit communication channel, which is a way that for developers to, it is a way that for the client to connect the enclave directly through this communication channel without reveal any data for a third party. And so what it means when we have this kind of primitives to build the TAE-based confidential computation, it essentially means that as a developer, you don't need to trust any third party when you deploy your application. You can verify the application, you can verify the platform by yourself. And as for a user, you don't need to care about anyone, including you don't need to trust the developers or the platforms, and that they can reveal the data, compromise the data privacy. So I think what is solved is the problem, is a trust problem. Okay, by moving from the confidential computation to confidential AI, which means in terms of the confidential AI, what we talk about specifically is the confidential inference service. And so by putting the LLM into the the TAE, what we want to get is first, for developers, they don't want to maybe they don't want to reveal the weights or the parameters to anyone. They don't even want to open source the code, but they'd like to like use the third-party service provider to host their large language model and serve more customers. And so they don't need to trust the service provider in this way. And for the users, and as I'm a user, I don't want to reveal my input and output to the, even for the developers or the service provider. I just want to let the LLM who know my data, and because I may send the sensitive data to the large language model. Okay, so here is the new architecture we need to design for the LLM inference in TE, and so the change is, for now we need to put the LLM inference, which is a GPU workload, into the TE. So we need the ML inference like accelerator, no matter the GPU or the NPU. So here we just take an example of the GPU here, and so by integrating the GPU into the architecture, we essentially need both the CPU and the GPU have enabled the TE, and the CPU and the GPU actually can share the data under the shared encrypted memory. And for now, we know that NVIDIA GPU like the H100, H200, and or the H20, which is a Chinese version of the H200, also both support the TEs, so we can leverage it to the LLM inference service. And so when we leverage the GPU into the architecture, compared with the CPU only confidential computation with the TE originally, for now we need to attest the CPU and the GPU at the same time. So for developers, also for users, they can have the way to verify the CPU and the GPU by the removed attestation report, because like NVIDIA, they already provide the SDK called NVTrust to generate the GPU attestation report, and they also have the implementation of their GPU attestation report verifier. So what we did under the hood is the GPU, when a user asks the platform to generate the removed attestation report, say they want to verify the platform, they want to verify the execution environment or the code integrity, what happens essentially is the GPU, the CPU TE, the program running in the CPU TE will first ask the GPU TE to generate the GPU attestation report. And the GPU attestation report would be sent to the verifier running inside the CPU TE, and the CPU TE verifier will verify the GPU attestation report, and they will bind the GPU attestation report and send back to the CPU attestation report to the users. So it a little bit mixed, but yeah, this is the way how it works. So the user can, when the user has the CPU attestation report, they actually can verify both the CPU and the GPU TE. Okay. By another problem is the secure communication channels we have mentioned just now, which is the third benefits of the TE-based computation, confidential computation. So. This is very important for the users, because for most of the scenarios, the user don't want anyone except the LLM can store the data they send to the LLM, no matter the developers or the service provider. So to achieve this, we have two approaches to build the secure communication channel by leveraging the TE. And first is we need to have a key generated inside the TE to use if we use the first approach like the domain-based TLS communication, the key would be used to sign the TLS certs, and in this way it's compatible with most of the clients like the browser and or you can use any like scenarios in the HTTPS. Another approach is to directly build a E2E encryption channel between the user and the enclave. So the key would be used to encrypt the data, and then the key also will be used to decrypt the data, determined by what algorithm you use. So, actually, we can do more if we introduce the external KMS and the blockchain technology. So let's take a look. And when the developers deployed their ARM into the TE, what they do is they want to someday they can upgrade their ARM, and so for this we introduced the KMS because what we did is we don't want to the whole desk encryption of the ARM inference service depends on the local key generated inside the TE. So what we did, we introduced external KMS. The external KMS would be derive the key for the application, for the instance, used to encrypt the desk. And for some days, the developers want to like just upgrade their ARM or potentially migrate their instance to another hardware. They can still decrypt the application data, use the same key. Or even some days the hardware is broken. They will not just they will not lose their data in this way. And with the on-chain KMS enabled, we actually gave a way that the developers can choose a method that they can involve the on-chain governance to manage the further upgrade of their ARM inference service. Okay, so wrap up the solution. Take a look at what we have today is, first we have the SDK called DStack, which is an abstraction layer to help developers to deploy any Docker application into the TE. And on top of that, we actually built together with the NEAR Foundation to have the private ML SDK, which is based on the DStack and add the support of GPU TE, so developers can deploy the GPU workloads like the ARM inference or the ZK prover into the GPU TE and with this SDK. And so the workflow would be when the user want to deploy the large language model into a GPU TE, first they will ask the remove attestation and to okay, give me the TE proof. I can verify if the platform actually running inside a Genius TE, and also check the code integrity with the one we published on blockchain, and then they can deploy the ARM into the GPU TE, and then the user who will chat with the GPU with the ARM, they can first ask for both the CPU attestation and the GPU attestation and verify it, make sure, okay, this ARM is indeed the one that the developers claimed and on their source code or maybe on their website. For example, if we deploy the Llama 3 or DeepSeek, they are open source, so we can check if it's really the official DeepSeek or the official Llama 3 image before we really chat with the ARM. Okay, so let's take a look at some real stuff we have built. First is we running a bunch of ARM into GPU TE actually, and they are live on the open router. And recently we just run a full version of DeepSeek R3, which means the 8 GPU cards with the TE mode enabled. And also, if developers want to build the private AI application, they can simply use the API live on the open router to build the private chat or private AI agent. The difference between the other OpenAI API with the one we provide is it actually has the endpoint. It can give you the TE proof. You can or we say the removed attestation report in TE. that you can verify or prove to your customers that your application, your agent is running inside the GPU-TE. Okay, so another case is because basically the DStack SDK support provide deploy any Docker application into the TE. So for now, no matter you develop the agent or the MSAP server or even RAG, you can just build the build the Docker build it into a Docker image and deploy it on with the DStack SDK if you have your own hardware, or you deploy via the Fala Cloud with several clicks on the UI. And here is an example I want to share is the shared agent developed by the NEAR Foundation. What they involved is basically two paths. First is the worker running inside the GPU-TE or the CPU-TE, which actually the worker can run the private key management or the ALM or the agent program. And the agent contract, which is running on NEAR blockchain, which can be used to verify the attestation report generated inside the TE workers. And by leveraging the NEAR intent infrastructure, we actually can build more like the trading agent, do the cross-chain swap, and even in the future pay the takeout or even swaps asset with Kraken. So this is I think the second case study I want to share. Yeah, that's it. Thank you. Oh, sorry.
So yeah, thank you. Thank you very much, Wenfeng. So the next thing on the agenda is the panel discussion on the topic is privacy without trade-offs, a myth. Now give us just 2 minutes just so that we prepare the stage and we'll continue.
On-chain, off-chain compute that's verifiable on-chain. So yeah, I think it's going to be a good discussion today with the right projects here.
Hi everyone, I'm Francis Ochudi, CTO at iExec. Just before we start, I wanted to give a big up for the organizers for this event because it's a beautiful place. And also Francesco, we've known each other for a long time, and I think it's the first time we are on stage together, so I'm very pleased for that.
Finally.
Yeah, you had a great presentation from Ricardo earlier about iExec, so I'm just going to say a couple of words about what we do. So we are a Deepin project. We provide a decentralized TE infrastructure, and you can see iExec as a trust layer for AI and any chain that is looking for ways to bring privacy, data governance, and trust to their processes.
Nice. Okay, so let's do it. How many developers do we have on the beach? I'm not saying in the room now, on the beach. Raise your hand, developers. So we kind of fine-tune also like some of the questions. So this panel is all about trade-offs, right? Do you guys think? Well, do you agree with actually this statement? Let's actually start from the title here. Do you agree that is privacy without trade-off a myth? Yes or no?
Yeah, I can start. I think it's kind of a myth because it's hard. Like even like selling a privacy product is already a difficult thing. Now you're trying to bundle privacy into maybe some good products, which may or may not compromise on like user experience or many other things. So eventually, I think everyone has to choose your own kind of trust or own compromise, right? If you're happy with, for example, using an iPhone, go for it. If you're happy with using, for example, on-chain, some of the mixers like Tornado Cash, yeah, bear the risk and use it. But eventually, it's based on your understanding of the privacy, and it's really hard to really have a full-fledged privacy product which has everything covered. So in the end, it's probably going to be a more kind of a composable way so that you can use privacy-focused product on one thing and try to like cover as many as possible. What's next?
Yeah, definitely can second that. I think we are focusing, of course, and we are very bullish with respect to TEs, but also there are other technologies that are definitely very interesting that we can look into, second multi-party computation, ZKs, and always when the user is supposed to use some of these technologies, they come with trade-offs. Definitely, I think what we see, TEs come with very good aspects that I think make the adoption better with respect to performance, overhead, and so on, that I think are very going in the direction of user experience. Also, it's much easier for devs to get onboarded because the technology itself is more understandable. You don't need to be PhD in mathematics to know how to write your circuits, and I think that is the part that we always have to consider as a part of the user experience, but definitely there are always trade-offs, performance, usability, you name it, and I think this is the part that it's also exciting because it's something that we, each of us, are working on and try to find and navigate the storm of trade-offs as a part of the journey.
Yeah, I mean, from my perspective, I think we saw last year or even the year before, you know, the Ethereum community, and I think Vitalik as well, was very adamant about, you know, ZK everything, right? But we saw that it's very hard to use ZK in a functional manner right now, you know. So we've been in TEs since the start, basically, right? So we see TEs as the best compromise, you know, where the compromise is basically on the chip manufacturer, you know, and this is what, you know, it's usually held against these, but I think it was interesting when the whole, if you remember when Ledger released the Recover product, right? And then everybody was up in the arms like, oh shit, you know, how can you recover the key if you can't extract it, you know? And then I think their CTO in one of his tweets, he was like, well, to an extent you trust us because, you know, if we would be malicious, we could actually create an update with the firmware that would be exploited, you know, and here there needs to be, you know, the minimal trust that's needed, and I guess the chip manufacturer is the one that's being trusted here, but at the same time, without it, you don't have any usable tech that you can support all the privacy applications that we need, right? So I would say TEs, it is a myth, and TEs are the closest thing to kind of enable us to build privacy solutions, you know, or confidential compute solutions that actually work today and now.
I think to answer that question, of course, I'm very bullish on TEs and what they will have to offer to end users. And at the stage where we are, there must be trade-offs. With Web3, we are really proposing an evolution or revolution of the internet, you know, moving from Web2 to Web3 is hard. So right now, there are some trade-offs we have to do. But hopefully, with you know, improvements on the user experience, we can get something that is much more fluid and simple to use for end users. The other thing I wanted to say is, for that question, it's a bit tough as a question because privacy on its own doesn't exist as an absolute thing. I think you're totally right. Privacy is very tied to trust. You know, privacy without trust doesn't exist. So I think the trade-offs will depend on, you know, how much trust you want to put into that thing. You know, if you want to, you know, go very hard on the trust, then probably it's not going to be as smooth as, you know, as you can imagine. Exactly. So I think that question is tough. So it depends on, you know, what the use case is, what, you know, what who the user is, you know, who the end user is, and how they want to go on the trust he wants to put on the solution.
Yeah, I think also like, I mean, if we're using the developer tooling side, right, is a total different kind of like debate here because giving instrument on top will also make the DevX totally like difficult, right? So we want to probably build like privacy preserving tooling for developers to spin kind of like CLI already with privacy preserving, and I think that's a big thing. So I kind of want to understand a little bit, like we dive in different topics. I think like obviously this is all about TE, but what are the kind of misconception around the space right now that you wish kind of like people are saying, oh, I didn't know that. And for you, obviously you guys are expert in the field. I mean, I'm feeling like a 5 years old, right? To get like all this information, like what are the kind of misconception? You touched on trade-offs. We can jump this a little bit later. But what are kind of like the things that you're saying, hey, this is something that I wish people knew before me jumping in all the technical kind of details?
Maybe I can start. I think probably if there was one misconception I would mention is the fact that there isn't one solution that solves all the privacy concerns when it comes to Web3. We can talk about privacy when on, you know, that is on chain. You know, how much privacy can we have on the transaction, on the exchange of value between participants? There's when it comes to Web3 application, there's anything that is not on chain that contributes to a decentralized application that also requires privacy. So for every use case, for every part of a stack, there's probably an answer, a different answer when it comes to privacy. So I guess TEs, we are very bullish here about what they offer. They're probably the most versatile way to implement privacy. But you know, it really depends on which layer and what use case you're talking about.
So I would just build on that. So basically, the misconception is also that it's exclusive. You know, either TEs or ZK or this, right? But you can use TEs for, you know, the general stuff, and then if you need more security guarantees, you add some ZK stuff as well on top of that, that for just the parts that maybe need to be more secure, right? So people are very combative, you know, very tribal when it comes to these discussions. But I think we saw, especially with the latest, you know, I remember in Bangkok, all the side events, you know, AI side events, all the presentations were on TEs, right? You can't really have AI with ZK, you know? So what's kind of the next best tech, you know, that has the small trade-off, but at the same time enables you to build now and build the AI solutions that we're excited to get in crypto. So here, I would say, the point is the misconception that it's all exclusive, but I think it's per use case, you know, and how you want to build TEs for general stuff, for more secure stuff, add ZK, I don't know, MPC, FHE, whatever, right? But probably the most important one is just, build something that works now, you know, not in 5 years, and stop dealing with theory,
I'd like to mention something that maybe most people don't really know. How many of you actually know that your phone has a TE as well, no matter it's iPhone or Android? Can you raise your hand?
Can we raise it as well?
Yeah. So this is kind of the misconception, because people thinking that TE is a new technology, maybe even coming after ZK, but in reality it exists way before. Ever since hardware is being produced, it exists as different forms, maybe a secure element, security chip. Even your credit card, it has such like tiny chip that protect the the integrities. Maybe in your PlayStations, in all your mobile phones, in Ledger as well, they have a secure element to guard the keys. So I think this is more like a fundamental technology that has been there for a while. And recently it got attention because all the cloud providers moving towards a more kind of aggressive roadmap. They're adding confidential compute as a new offering. Also AI probably have to live on TEs, because otherwise you couldn't really have the performance, right? Especially on GPUs. So I think this is probably the misconception I can think of right now.
Yeah, something in a similar direction, right? Like TE as a technology is sometimes just put together as like one box that, okay, TEs don't work. But if you look at it in detail, there's variety of TEs and the implementation differ. And many people, like when they are comparing TEs to other solutions like ZK, many times they also just like ZK is better. But you have to also look actually into the implementation of the ZK. Whom do you trust? Like, do you trust that all of the rollup providers are actually implementing this stuff properly? Maybe, but there can be also very severe soundness bugs. Even though the math plays out, it doesn't mean it doesn't translate into the implementation. And I think this is many times the misconception that we are using ZK because it's secure and everything, but actually it's possible that you might have issues in the implementation. Same actually as we oftentimes see in the TE, but it doesn't mean that TE as a concept is broken, it just means that there are issues that can be resolved. And this is, I think, what the community should be striving for. Be transparent about the issues and look for the ways on how to resolve it. So I think this will be an interesting step. I think that we can build the trust to the users as well.
I mean, I think also on the use case, right? I think it probably depends on what your actually are implementation requirements for who also you're implementing. And I think there are so many debates since Denver. I'm hearing so much kind of like what's happening around trade-off. But actually speak about trade-off, right? Everybody's speaking about, okay, trade-offs around scalability. I'm more interested about trade-offs around composability, UX specific. Now we can speak about user, then we can dive deep a little bit more on developer, even if there are not many devs on the audience here.
Yeah, I think with respect to trade-offs, if you look at it, I mean, talking about TEs, we see that the main fundamental directions are either you go with process-based TE, where you can have your application that only certain components of it as a part of the process are running inside of a TE, or you can go and choose a VM-based TE, like Intel TDX, AMD SCB, SMP. And these solutions, of course, have their own trade-offs with respect to looking into that, and I think as a part of the journey of a developer, with respect to using VM-based solutions where you can put the whole virtual machine, you think that if you just deploy anything inside of the virtual machine, you solve all of the problems, but actually it's oftentimes not the case, right? You have to actually build up the whole stack, make sure that the reproducible builds are in place, make sure that you actually try to minimize the trusted computing base to provide very robust and strong guarantees with your deployments. Whereas if you use, for example, a process-based solution, you actually have to really pinpoint what is the stuff running inside of the application, but the TCB is much smaller, right? So already just like looking into the fundamental directions of different type of T technologies, you can actually see many trade-offs that can later on impact composability, usability, and many other aspects. So this is definitely an interesting space to dive into.
Yeah, I think if you're using TE, probably you are making less trade-off than other technologies because first, you don't have to migrate your code. You could just make it running in a VM-based TE easily. Second, you could just run pretty much everything. There's no programming language for TE. It's just basically everything. Even you can put a Linux running inside it. Compared to other tech, you probably have to really tailor-make your code so that it can run in so-called VMs, right? And also, there's no trade-offs you need to make in terms of like choosing clouds or bare metals because all of them are supported nowadays. You could just like maybe go for the one with the lowest pricing, right? That fits your need. And other things, I think right now also like most of the TEs are secure in terms of like enterprise support because I mean those manufacturers are like Intel, AMD. They have been doing this for long while. Even NVIDIA as well. They recently have TEs in their GPU as well. So I think, I mean, at least we have a couple of big players out there. They will covering a lot of security as well because they care about their reputations. I'm not saying we're going to rely on them, but I would say it's more like battle tested because they're running business for many years already.
I mean, from my perspective, what he mentioned, right? The reproducibility here is key, right? So you can slap on a TE to any app, you know, but then if nobody can verify, you know, what's running in there, you know, and build it themselves, then you didn't really do much, you know. You just, you know, enable them to run something in a black box and say, oh, we're running a TE, we're secure, right? So here I think, there's no trade-off for the devs to run stuff in TE, but at the same time, the implementation needs to be done in a way that actually, gives the added benefit of verifiability to it, because you didn't do much. It's more marketing than anything else. If you don't go all the way of, you know, making the reproducibility of the builds, you know, and you can compare that, that code is actually running inside there and it's being executed as it's meant, right? This is something that we are truly focused on, you know, that it's not just, you know, using TEs for the sake of it, you know, but having the full flow, full stack, and make it easier for the devs, because this part, you know, can be complex for the devs, right? So we are building on frameworks that make it very easy, you know, so it's like just a CLI command to build it out and then to verify it as well, right? And then even putting that into a UI, so users, the same as they can go to a block explorer and verify that transactions happen there, that they can go to a block explorer and have a similar verification, you know, of the TE code execution. But that's real. That's not just a check mark there, a green check mark, oh, we're good, you know, that they can kind of build out, let's say, provide the code, you know, that's running, build it out through a UI potentially even, you know, and have that reproducibility. Because, you know, crypto is all about don't just verify. So I think we need to try to keep that ethos. But yeah, just running in there, I would say no real trade-offs. More people should do it, but unfortunately there's not that much demand from the market, right? People are used to transparent chains, people are used, you know, everything running in the open. and then usually offloading to off-chain, on non-verifiable off-chain compute for more complex stuff that they can run on-chain. So I would say it's a mind shift that maybe we need to get to, right? But I think the awareness and the narratives developing now are moving in the right direction.
Yeah, nothing much for me to add on that. I totally agree with what you guys said, and I think it's not a trade-off. It's probably some kind of engagement that we have to do as builders or platform or solution providers. Is how do you translate that value to the end user? How do you, because as you said, it's not, you don't know if that thing is running in C. So how do how do we educate? How do we evangelize the benefits of TE? That's something that should be considered when providing such solutions. So, because we are talking about black boxes, application that nobody can inspect or interfere with, but from the end user point of view, it's not, it sounds magical. So there's some education to do as well.
So, it's very interesting what you're saying around black boxes, because one of my criticisms was also, when we define pure kind of like backend technology has some kind of PMF in the ecosystem, right? So I want to ask you kind of like, this is a bit spicy, right? But what are the metrics that we see today? What are the attributes that we should care about? Are the number of companies, are the number of like user onboarded through kind of like, kind of like a backend kind of ecosystem? Are the performances, what are those attributes? And what is this adoption in numbers? What are the metrics that if you meet me in 6 months, you will say, hey, Francesco, we have X, Y, Z of this compared 6 months ago, and this is getting adoption, right? Because I feel a bit that we are, we were speaking exactly about the same in Denver, and I miss these numbers. But I'm sure there are numbers. That's why I want to hear from you guys.
Yeah, maybe I can start. It's a nice question. No, I think when it comes, something I probably didn't mention earlier is that today there are infrastructure providers. You can buy a machine that is T-enabled with TDX, AGX. You can spin it up and get it running. But then you have to do all the plumbing around it to make sure that your entire solution is secured. So at iExec, the KPIs and the metrics that we use is total value secured, for example. So that means what are the assets that our users or our users, so the end users, what are the assets they are protecting through our platform, and how many operations, how many tasks or applications are running against those protected assets. So that's how we measure the traction. That's how we see that we're adding value and providing value to our end users.
Francesco, we're in crypto. We don't talk about that stuff, No, joking. I would say it's similar. For me, it's how many applications are running using TEs, and then obviously the number of users that they have, right? You can have 100 obscure applications. That doesn't mean a thing, right? And I think, let's say even Unichain, I think will be using TEs for block building. They're doing something with flashbots, right? If I'm not mistaken. So I think adoption like this, where you have applications that already have a lot of users, and then introducing the tech to improve, their solution as well, kind of raises the awareness around the user. So for me, it's more, obviously, secured assets is one, but you can also have logic where the TE kind of, maybe just manages, across certain contracts, certain assets. So it's not exactly locked in the TE, but the TE has some control over it. So I would say number of applications, and then subsequently number of users as well is a metric for me to kind of see the growth. And as I said, Unichain for me is a very good example of it. And I think we're going to be seeing more and more of this because there's just no reason not to use it, right? It's the same as with it was with HTTPS, right? At one point, everybody was looking at the green padlock when they were interacting with the website. If it's there, so they're safe to input their data, right? And if it wasn't, they wouldn't interact with your website. The browsers started, popping up warnings. So maybe we have a similar solution, where, if something won't be running in the TE, you're gonna get a warning. This is gonna be pushed out, broadcasted, whatever. So let's see where we come, right? But something like that. The adoption is through, let's say, I would say, number of dApps correlated with the number of users. Yeah.
Yeah, I actually have a couple of the high-profile project names to add to your list, following Unichain. Word ID, they're actually using TE for their MPC protocols. Within the rollup ecosystem, a lot of ZK rollups or even optimization rollups, they have TE prover or they are building a TE prover. If you look at their code base, they have even engineers working on TE submitting to GitHub. And also, especially in AI space, recently, also this one comes with some solid numbers as well. The one done by Magic Link, they have a agent project called Newton. I think because they're using our library on chain to finish the attestations for the TE. So far, we've seen over 700K attestations on base chain. And the reason they choose base chain is because it's affordable to them, and that's kind of telling a story of how affordable it is right now to run attestations. Previously, people thought that it's going to be expensive, but in reality, now it's usable. I would say maybe soon, maybe in 6 months, I can bring a larger number to Francesco for you to check. Yeah. Okay.
So as a space computer, we are rather an early stage project, right? So we still don't have our users, but with respect to the technology, we are very motivated to actually see that there is a lot of traction happening, which also motivates us to definitely see that if we launch and deploy our own space TE running on satellites in space, there will be definitely interest in providing an offer high secure validity of basically and a place where we can actually store high value in a unique environment. And at the same time, we're also actively actually working with on Earth TEs as well to basically see how the technology is evolving. And at least from that experience, when looking half a year ago, how we can actually see that the development of the tooling and so on is improving and how many commits are being pushed regularly, is also giving us a hope actually that our future with respect to what we want to provide with a space TE and space computer is going in the right direction, because it's basically validation for our thesis of providing security is something actually people care about, and the adoption is there because also the tooling is there and more use cases are because of that also being unlocked. So we are definitely very optimistic and bullish in this direction as well.
Yeah, I'm super optimistic. Also, the space in 1 year has been developed quite aggressively. You touch on tooling, what are we missing right now? Is there some kind of things that you touch on the CLI? I think precompiled CLI is the way to go, especially on the DevX side. Do you feel like there's some kind of missing pieces in terms of infrastructure for the? I will just target right now developers that are consumer dApps developers. So people are dealing with front ends every day. They just don't care. They want to have privacy preserve systems. So thinking about this, what are kind of the missing infra pieces that we need or we see we should build? I mean, we're all builder here that you recommend us to start building.
Yeah, so if I can start, definitely I see that there are challenges with respect to reproducibility. So the tooling, of course, when you look into Nix or other tooling, they are there to provide the reproducible builds, but it's not very user-friendly. So I think pushing forward to really have a Docker-like experience when you can define all of the details for your application and deploy it will be perfect. So I think there is a good direction, but still I think it's gonna take some time because the problem itself is not easy. Many languages you have to support and other parts that are actually making the life challenging. And second part, I see that many projects are trying to reinvent the wheel. So I think coming together as a team, trying to share the notes in some way and come up with a good standard practices, what we all can agree on to provide and make sure that the design patterns are aligned among all of us, I think would really make it easier, because there are a lot of stuff that you can do wrong, unfortunately, when it comes to leveraging TEs, and this can of course lead to leaks and other aspects. So I think that will be two dimensions I see could be improved on.
Yeah, I actually have a little bit concerns on all the front ends, because I actually don't worry about anything about the back end, because given time we can make it better, people are going to build on it. But nowadays on front end it's a different story, because if you want to host your web app via TE, you will hit the issue of how gonna you use CDN for this kind of thing, right? Because CDN gonna break your TLS connection so that your user won't be directly interacting with your TE. In that case, it's like a middleman sitting there. They can do anything they want. So I think this is going to be maybe something that people can build, which is preserving this kind of end-to-end security between users and TEs, while you can still have CDN's benefit.
I'm probably the least technical person on the panel, so I'm going to simplify kind of what we're building in terms of, enabling easier interactions for the developers, with TEs. And it's basically this framework that we call ROFL that Yannis spoke at the beginning, right? And where, if in very simplified terms, you have a Docker compose file where you put everything which you need and want in there, and then you just run a command Oasis ROFL build. And then the other one is Oasis ROFL build verify that gives you the reproducibility, right? So kind of building these frameworks that obfuscate away a lot of the complexity, right? And then have all the kind of verifiability in a very simple UX for them. It's in CLI. We're actually going to be, it's launched today. It's ROFL app, ROFL app, which is kind of UI where you manage your TE apps, right? Apps that are running on ROFL, and just enabling this ease of interaction for anybody. Like we even have like a relatively no code flow for novice devs or white coders or whatever, right? Mm-hmm. Where they can use some templates or create their own, launch them in the TE. There's a marketplace for providers to provide their infrastructure for certain pricing. So trying to really obfuscate away all the complexity while not compromising on any part of the verifiability and security. So we're exactly in this kind of lane, building towards making it easier for devs to utilize it without thinking twice.
Yeah, also I can definitely relate to what you said. The challenge for a project, for our kind of project, is to make the protocol itself accessible to developers, and that's been our focus for the last year and a half. We started with very easy to integrate privacy-preserving applications. First ones were around messaging, to integrate the ability to send messages to Ethereum addresses without disclosing the actual email address of the end user. So we started with very easily integrable SDKs within the applications, and now we released the iApp generator, which is a scaffolding application that generates the bones of your T app. You write your logic, and you deploy your application in a decentralized T infrastructure, T platform. So I think hiding all the plumbing is nice, but obviously you need ways for the developers to attest, to see exactly what is happening and what's going on with, behind the scenes for its application. So it comes with having CLIs and SDKs that are comprehensive enough for builders want to go much beyond the simple command line.
Okay, sounds good. I think we covered kind of like from users to kind of like trade-off, challenges, what is missing. I think, but everybody is kind of like optimistic. So I think we will meet in 6 months. We will say, okay, this is how we're moving forward. So we are on time, guys. I just want to make sure that everybody's awake. Did you guys learn something new about TE today? Yeah? Okay, so raise your hand. Okay, good. Thanks so much for organizing this. Thanks so much for your time, for listening to us. Big round of applause for our panelists here.
Alrighty, thanks guys. So we came to the last part of the agenda. Let me invite on stage Dylan, who is the CEO of Automato.
Founder of Automato. So in a very nutshell, Automato is a Web3 agent builder, and we integrated Oasis and iExec. So very quickly, Web3 move fast, but you're always too late, and you sleep, but the market doesn't sleep. So that's why we build Automato, to automate and create your own AI agents in a simple way. So drag and drop an AI agent where you can just like type your prompt and your agent is getting created. So this is me and my co-founder. So at Automato, what we do is we automate everything. So imagine you have a position on Hyperliquid, you're about to get liquidated, so we are able to receive a message on Telegram saying, hey, be careful, something is happening, you're about to get liquidated. everything is just with one prompt. So you will be having like a Telegram message, you can choose email, etc., etc. Or you can have something like every 5 seconds, move my liquidity to the best yield. You can automate everything on the Web3 market. But alerts are cool, but action is even better. So we just don't alert, we execute on your behalf. So imagine you have 6% on Aave, 10% on Morpho, and 9% on Moonwell. What we do is we will always get the best yield, allocate your liquidity to every time a new opportunity arises. And so you, thanks to Automator, you will get like 12%. And the best out of that is you can be protected, because if we see that on-chain there is like a hack or whatever, the block after the hack, we can withdraw the liquidity for you. So we optimize and we protect thanks to agents that you configure in one prompt. So yeah, so that's the vision that we're about to arrive in very soon. So I will really quickly, it's like, hey, careful, your hyperliquid position is about to be liquidated. Do you want to add funds? Yes, no. If you say yes, you can just say like, yeah, add some fund. You have 5,000 available. Should I add fund, 25%, 10%, etc.? Yes, put 1,000. Okay, good. I added 1,000 to your position. So this is the AI agent that's talking. Then okay, now your position is 115%, you're now safe. So this is all the power of the AI agent that we're doing. It can be notification, it can be optimization, protection, etc., etc. So we integrated also iExec. You can just like, this is how the platform look like. It's a kind of like N8N or Zapier for Web3 on-chain. So then you can have like protected email, protected Telegram, etc. You can choose everything. And yeah, so how do we do that? We integrated all the Web3 protocols. We integrated everything, on-chain, API, Telegram, Swap, everything. And we just like plug with a no-code app with just few clicks, and that's about it. This I don't know. Okay, so this is a small video. You just put like, okay, sell $100 BTC whether Trump tweet about tariff. It didn't work. Okay. Okay, the video doesn't work, it's fine. So then what happened is like, okay. Okay, I moved. Okay, anyway, the slide's working. Anyway, so you just like put a prompt, like as I said, like every 5 minutes, move my liquidity, or if Donald Trump tweet about Bitcoin, we're checking like Twitter, on-chain, off-chain, etc. You build your AI agent, the AI agent run for you, and it does everything on your behalf. So I'm just stuck on the slide, maybe. Okay. Okay, anyway. So I'm done. Yeah, so if you want to talk about it, so my slide is like broken, I don't know why, it's the Google slide. But anyway, so this is how we do. We build AI agent with just one prompt. You can have like everything on-chain, off-chain. You can build like automation, just alerts. You can optimize your yield. You can just build your own agents like Zapier on N8N, but on-chain and native on-chain, so you can deposit money, optimize, etc. So if you want to talk about it, just like come to me, I'm at the event, and we'll be very, very happy to explain you and to collaborate. We have an SDK. You can plug it into your own platform to, in just 3 clicks, optimize everything, and no code, low code, so everything. Thank you very, very much, and see you soon.
Well, thank you, Dylan, and thanks to everyone who stayed with us until the end. So yeah, this was the last presentation. Yeah, see you around and have a nice